Spectrum storage, right? We have sort of spectrum compute and we have spectrum storage. So let's focus on spectrum storage. We have sort of four things underneath the software-defined portfolio. We have spectrum virtualized for virtualized SANs and block, a classic piece that's been out for a long time. We have spectrum accelerate, which is built out of the XIV software. Spectrum scale, a specialty in unstructured file data, really well known in HPC. And then also for object storage, we work with IBM Cloud Object Storage. It's kind of a sort of part of the software-defined portfolio. But that forms the grounding, and then we have Spectrum Archive for tape, so you can do VTL just in software, and we have Spectrum Control, Spectrum Insights, and Spectrum Protect for management and backup. And this week here at Edge, we just announced Spectrum Copy Data Management. So that makes up the entire portfolio of Spectrum storage. Spectrum Copy Data Management is definitely a partnership program for us. It's one of the things about being able to bring mature cataloging into it, the portfolio. But one of the things you have to think about with Copy Data Management is it actually does work with the snapshots that are in Spectrum Virtualized, Storewise, the A9000 family, the snapshots that are part of the software-defined piece to create a catalog, orchestrate, and move data around. So it's a really nice complement, not only the software portfolio, but the entire IBM storage portfolio. So it'll be, I think it's going to be a very exciting addition to the product portfolio. IBM Spectrum Scale is actually built out of a 20-year history in high-performance media and compute. GPFS is what it was known as many years ago. It's completely evolved into a much more user-friendly, multi-protocol, multi-environment, multi-cluster data storage for unstructured data. It supports file, it supports object, and its very unique capabilities are the ability to do data placement, data movement, and data tiering. So it's a very intelligent way of handling large-scale big data environments. It allows us to do archives and analyze in place with HDFS connectivity that's transparent. And one of the things we've been talking a lot about this year is how it helps enable moving into the cloud with transparent cloud tiering to IBM Cloud Object Storage, but also to public cloud. IBM Spectrum Scale has a pretty mature information lifecycle management and policy engine. It actually even has a setting that says get data from the fastest place it can, just based upon latency. And it has things like caching and ability to understand a certain amount of latency and distance. So in the case of if we put something out into an object storage, which will have a higher latency than the local disk, or even a higher latency than if we had it in flash on the box, it actually understands those as different tiers, and we mitigate some of that latency in 2 or 3 important ways. One of the most important is the metadata is actually all still managed and taken care of within IBM Spectrum Scale. That helps a lot for the classic directory searches, indexing, all the things that you expect in terms of usability and speed. But then we also have an underlying transport technology so that we can deliver first bits when we need them, as opposed to having to do full transports of buckets or files or moving data back and forth. This is not a gateway technology, but really a true bridging that we can move files into clouds and be able to do cloud and object data together with the intelligence of Spectrum Scale behind it. One of the things that we're looking toward is to be able to leverage the automation policy and data placement and data movement that already exists and is very mature in IBM Spectrum Scale to actually make it much more cognitive. IBM's vision of what cognitive storage is much more than just some data awareness and pattern matching. It's actually pattern learning, and it has to involve not just the physical storage, the latency, but multi-protocol and user access patterns. And we already capture a lot of that as part of our metadata environments in Spectrum Scale and across across the portfolio with Spectrum Control and with Spectrum Storage Insights. So we have the ability to start getting all the pieces and parts in place, and it looks very cognitive in how it works today, but we have ambitions to really make this know more about what's going on, self-optimize, and actually pull some of the information out to create policies on its own that would be approved by administrators. So you could do things like resiliency, you could do things like by type of user. All these elements are already in place in IBM Spectrum Scale and across our portfolio. We just need to integrate it all together into an end-to-end view that is much more autonomous, much more intelligent, and a much greater vision. But all the elements you were talking about, John, today, of policy-driven, understanding the data within, not just matching where the targets are going to be and the status of the infrastructure, is all actually already in place with IBM Spectrum Scale. In the case of ingestion, it really is, IBM Spectrum Scale has the ability to use already existing storage as one of its underlying targets and ingest either NFS or even HDFS data and run with it, use it in place, and migrate it and move it per policies later. So the data for classification does change constantly, which is why when we talk about where we go from policy-driven storage to sort of cognitive storage is the ability to reassess the patterns as they emerge. We already have the concept of heat, and we have the concept of data reliability built into sort of the way Spectrum Scale addresses some of their policies, so you can do things on changing metadata, changing policies, changing use cases. And then the last being in terms of data movement. And when the things that's really changing the market right now, we have such big data environments, and we have to drive down the TCO of the overall portfolio and make it useful in different places. It needs to be useful for archives, it needs to be useful for analytics, and it needs to be useful for silly things like, I want a web page that just lists it all through a nice Bluemix application. That would be the fastest way to do sort of quick search and index against objects. People want all that kind of usefulness across those different types of data types, all looking at the common sense of a data ocean. And IBM Spectrum Scale, especially when combined with IBM Cloud Object Storage and the rest of the portfolio, gives us the big building blocks for those new age of applications to be able to actually be able to do that with the ingestion, with the classification, and with the movement. The all-flash everywhere folks inside of IBM are a really wonderful complement to this environment, because what we're really looking at is the ability to do a serious tier of flash up front and be able to migrate and mitigate data off of it. If we're talking about analytics, flash with its low latency is a really, really fantastic target for that if we can get the price points down on the overall storage portfolio. So we actually do really well together. Well, in Flash, and one of the tier list problems is Flash is actually the right target for working sets in a lot of ways. But the reality also is that the cost per gigabyte, cheapest, easiest way to do that is definitely still tape and highly reliable. You can't throw out the baby with the bathwater. What people want in terms of flat and frictionless is end users and applications never have to switch or move. And the IBM software-defined vision and the IBM software-defined products we have today, whether that's Spectrum Virtualize in order to virtualize out on the block level, or Spectrum Scale to do it with file and object, really allows an environment that appears to the end user and the application as flat and frictionless, and the storage administrator has tools and knobs and things that they can use to drive down the overall cost and still maintain the reliability of the data that they need. It's actually flat and frictionless may be something we start to steal in terms of how end users perceive the storage portfolio, but it's not how economics drives the actual physical storage to be.